All right. Well, thanks again for joining. This will be a relatively short office hour. I guess technically not an hour. I've got about 30 minutes today, so I'll take what I can in that window. This is another one of the pop-up sessions, I think, where I'm going to talk about mainly some real-time events or things that might happen next week rather than a more planned session where I have a conversation about the longer term, although I think fair game today also are questions about the future of snow in a warming climate in California, because I think that that's a relevant question, and the answer may be somewhat different from what a lot of folks might assume. But the main focus of today's conversation is to discuss the really cold weather coming up next week, the likelihood of snow in California at unusually low elevations, sort of the historical context of events like that, of low snow events in California, and then also why we really shouldn't be taking the weather models very literally when it comes to events like this, and why a lot of the claims made on social media about both this specific event and other kinds of events that have occurred recently that did not play out anywhere near as depicted literally by weather models. Well, it's essentially why human meteorologists still have a job rather than just having everything be automated. So, quick summary of what it looks like is going to happen next week. Just to emphasize, all of this is still 5 or 6 days out. In fact, it actually looks pretty warm and mild this weekend. There's a storm offshore right now, California, but it's really looking like it's just going to make for some clouds, maybe some pretty sunsets the next day or two. It does not look like any of the precipitation this weekend is going to make it onshore. Should be pretty mild. Next week, though, pretty big pattern change where a very cold air mass over the Pacific Northwest and the interior of British Columbia and Alberta will spill southward somewhat, and some of that cold air is going to get picked up into an offshore low pressure system, one that is just offshore of California and the West Coast generally, next week, and as it does so, it's going to wrap in all that cold air with a little bit of Pacific moisture and bring some interesting weather next week. And I'm deliberately being a little bit euphemistic about the word interesting in this context because it still isn't totally clear exactly what's going to unfold. Now, what I think has made a lot of folks excited on the internet and has been making rounds on social media are snapshots of weather model predictions showing significant snow accumulations in the city of San Francisco and Sacramento and all throughout sea level in Northern California. Well, I'm here to tell you that unfortunately, I guess fortunately or unfortunately, because it would be quite the interesting novelty, but it would also be tremendously disruptive. For better or for worse, that almost certainly isn't going to happen. Nonetheless, some interesting things probably still will happen next week. So what do I mean by this? Well, one of the things that's been circulating online, as I mentioned, are these model snow maps, which in the meteorological community, in places where snow is more common than it is in low elevation California, this is often the topic of some amusement and derision online, because folks will post model snow maps for outcomes that are, meteorologically speaking, patently absurd, like huge snowfall accumulations in places that almost never see it, or large snow accumulations at a time when the temperatures don't really look like they're supportive of snow versus rain in the first place. And there's a number of reasons why this can happen. One of them is essentially a deficiency of the surface scheme in some of these weather models, which is known to produce sort of be overly aggressive in saying that the precipitation will fall as snow rather than rain. So it's correct essentially in that there would likely be precipitation during these periods of time and in these locations, but they're wrong about the phase, solid or liquid, of the precipitation, so rain versus snow. And one of the reasons for this is that some of these models tend to over-predict how cold the boundary layer ends up getting, so the surface of the air that we live in and is right above our heads is often not as extreme as depicted by some of the more recent iterations of weather models. So this is a known systematic bias that essentially arises mainly when conditions are unusually hot or unusually cold, so it can make surface conditions even hotter than usual during extreme heat waves, or even colder than usual during anomalous cold waves, in an unrealistic sense. So in the real world, it may well be that it is extremely hot or extremely cold relative to typical conditions, but the weather models, their surface scheme kind of overdoes it during the extremes in both directions. And when you're close to freezing, you can imagine how even if the model's only a degree or two off, if the air temperature is more like 34 or 35 degrees instead of 32 degrees, that can have a pretty decisive outcome on whether you get rain rather than snow. So one thing I think is happening in some of these model outcomes for next week that have at various points depicted ridiculous amounts of snowfall at sea level in Northern California. These don't appear to be physically realistic, even with the vertical thermal profile that the very same models are predicting. So in other words, the temperatures in the atmosphere above the ground that these models are predicting don't really match with seeing snow at sea level in most of California. It's not cold enough. Historical events that have had similar temperatures in the atmosphere did not produce widespread snow at sea level, despite what the models are saying. So I think this is partly a case where that bias is coming into effect. And I also think that there is also the reality that when folks are looking at ensemble models especially, so the coarser resolution, meaning the spatial resolution is not as finely spaced as the ordinary operational runs of the weather models. So we're getting into some of the weeds here. But the point is essentially that for the ensemble models, you kind of have a blocky representation of the topography. So much so, in fact, that it can't really specifically resolve the coastline. So, for example, coastal cities like Eureka or Santa Cruz, the model thinks that they're about halfway up into the coastal mountains. So when you extract a time series, plot, for example, from one of these coarse resolution models for something like the city of Santa Cruz, it's extracting a point where the model thinks is about 1,000 to 1,500 feet above sea level, where it very well may snow next week. But it does not mean that it's actually likely to snow in the real world city of Santa Cruz, which is right on the ocean for the most part, aside from some hills on the eastern and northern sides of town. So just an example, there's two key reasons why this is likely happening. One is that there's a known issue where the models are a little bit overly eager in producing snow at the surface under marginal conditions. And number two, essentially that some of these places that folks are seeing on snow maps in these models aren't really at sea level according to the model itself. They're sort of this just overly coarse representation of the topography, and so you end up getting model representation of California that looks kind of like a block world or Tetris, or I guess I'm blanking on the video game that sort of Minecraft, the big blocks there, for those of you who are familiar with that. That's kind of what the world looks like in a weather model, especially in the ensembles where the blocks are pretty big. So there's some smoothing, unwanted smoothing that sort of results in this effect. The other interesting thing is that there have been, historically, a handful of events in living memory, at least for folks who've been in California for decades, where there was widespread snow at sea level. And I'm not talking about isolated pockets of snow. So it snowed near sea level in California as recently as last week, up near Eureka. In fact, it's happened almost every year recently up on the north coast near Eureka, at least briefly, where sea level snow is not nearly as rare as it is everywhere else in California. Places not quite at sea level, but pretty close, have seen snow in recent years, notably places like Redding and even some of the other northern Sacramento Valley towns that are a little bit lower elevation. Sometimes folks forget, though, Redding is actually parts of town, most of the town is above 500 feet elevation. Some places are actually above 1,000 feet in the outlying areas. So there is some elevation to work with there, and it turns out that last 500 or 1,000 feet makes a really big difference. Snow at 1,000 feet in California happens every year or so. Snow at sea level hasn't happened in any widespread setting, hasn't happened in decades. It's actually been essentially since the 1970s. The 1976, I believe, was the last year when there was widespread snow in places like the Bay Area at sea level. Now, again, widespread snow in the Bay Area at higher elevations happens every few years. I can personally recall many occasions from San Francisco Bay Area where there's snow on the hills. When I was a grad student at Stanford, at various points, I went up into the Santa Cruz Mountains when conditions were favorable and saw pretty significant snow accumulations. There are actually a couple of snow plows that are stationed up there in the Santa Cruz Mountains because there are state roadways that go above 2,000 feet elevation, which is high enough to get fairly consistent snow some years. So I've been up there on my bike from Palo Alto and in a zip car, which turned out to be the bigger mistake. But anyway, it does snow in the Bay Area. You just got to go up high enough. And there are, isolated instances of, I think, sea level snow or close enough to it in recent years where an isolated shower occurs in an area where the air temperatures are really cold. Usually this might happen in like the early morning hours for the most part, but sometimes at other times where you're right at the edge of a cold air mass, and essentially the air mass doesn't have time to modify itself enough to really prevent that snow from making it all the way to the surface. So it may not accumulate very much, but it does make it all the way to the surface on an isolated snow shower basis. That does happen occasionally. In California, in the Central Valley. It even happened a couple of years ago in Salinas, and I think the slightly higher parts of Santa Cruz, so perhaps not on the beach, but on UC Santa Cruz campus, parts of it are a couple hundred feet above sea level. Isolated snow showers can happen there, but it takes a lot more than that for a widespread sea level snow event in Northern California, because, well, that influenced the Pacific Ocean really. Is just too powerful. That nearby ocean is just too warm. And generally speaking, air masses that make it to California that are precipitation bearing go over the ocean before they make it over land. And so they are known as modified air masses. And we can get Arctic air masses in California, but they're most commonly modified polar air masses because the cold, dry air from the polar region then goes out over the Pacific Ocean, gains some moisture, gains some thermal energy. It just simply isn't as cold, especially in that lowest layer of the atmosphere, that boundary layer, because that exchange between the ocean, which, it's a chilly ocean. It's not like it's a warm ocean off of Northern California, but of course, in relative terms, even if the ocean temperature is in the 40s or 50s, that's still much warmer than the temperature of the air at the surface that you'd need for snow. And so as that exchange of cool but well above freezing ocean water with the lower atmosphere modifies, that has a warming effect on these Arctic air masses, the lowest portion of the atmosphere just tends to be too warm for air masses that come in over the Pacific. They can be really cold aloft, so the air even 1,000 or 2,000 feet up can remain at or below freezing. And that is why it's not that difficult to get snow in the hills of Northern California, even sometimes down to 1,000 feet or so, so even in the Bay Area. And even in Southern California, sometimes you'll get snow in the high deserts or the inland valleys at a higher elevation up around 1,000, 1,500 feet for the same reason. The atmosphere cools really rapidly as you go up, much more rapidly and much more consistently, I might add, as you go up than as you move horizontally. So that elevation really is in your favor if you want to see snow. And unfortunately, if you're at sea level in California, it's always been hard to produce sea level snow, and it's getting, in a warming climate, of course, that much harder. The one pattern that could produce sea level snow in California, and I suppose still could happen, even in a warming climate, although again, it becomes less and less likely as background temperatures warm. The one kind of pattern that has produced it, and this is what happened in the 70s, the last time there was a widespread sea level snow in California, is what's known as a retrogressive pattern, essentially a very cold air mass in a similar position to the one that we currently have over British Columbia and the interior of the Pacific Northwest, so over eastern Washington, Idaho, western Montana. But the key is that air mass, it doesn't just need to plunge southward, but it actually needs to move southwestward. So it actually needs to move against the prevailing west to east winds a little bit through a very unusual jet stream and wind pattern so that air mass can stay dry. So the key part is it moves into California from the northeast without moving over any water. So it just comes straight over the continent, essentially as an unmodified Arctic air mass. So it doesn't have that influence of the Pacific Ocean, even though it makes it all the way to the Pacific. Since it comes from the northeast, it goes from land to seas. In other words, its extremely cold offshore flow, if you will, is the kind of pattern that results in the most damaging freezes in California from an agricultural perspective in the Central Valley, and also those very rare occasions where you actually have the potential for meaningful or widespread sea level snow. And these are not wet patterns, by the way. These are very dry patterns, but occasionally there might be just enough moisture or just a weak enough disturbance to produce a little bit of precipitation. And when the air mass is that cold, when it's coming from the northeast, that is where the potential exists for extremely low elevation snow all the way down to sea level. So again, that pattern is rare. Arctic air masses are not as cold as they used to be in winter, so it's getting harder and harder for them to maintain themselves, even if we did get that pattern. But I wouldn't rule it out. It could happen again in the future. This, though, this coming week, this is not that pattern. This is not the kind of canonical synoptic weather setup that you'd expect to produce sea level snow in California. And so despite what some of the weather models have said, I think it's extremely unlikely that there would be widespread sea level snow. That said, this is going to be an exceptionally cold air mass given that it will come in from the ocean side, so there will be a fair bit of moisture associated with it. And in that context, this is a surprisingly cold air mass. And there's some indication that the 850 millibar temperatures, for example, could get down to -6, -7 degrees in some places. That's very cold. For so low in the atmosphere over Northern California at a time when there probably will be some precipitation around. So what do I think this is going to look like next week? Well, I do think it's quite likely that places down even to 1,000 or 1,500 feet could see snow, perhaps significant accumulating snowfall, and that's going to be really disruptive in that 1,000 to 2,000 foot elevation band in particular, because that's a part of California that doesn't ordinarily see more than flurries or a dusting, and they could actually see rather significant snowfall. Some places I think that could really be hit hard by this include the lower parts of the coast ranges, so much of Lake County, parts of Mendocino County, going all the way north to the Oregon border along the north coast, the foothills ringing the Central Valley, and not just the northern Central Valley, so not just the Sacramento Valley, but also the San Joaquin Valley, the foothills, again, not the valley itself so much, but the foothills down to, say, 1,000 feet or maybe even locally lower. Places like Redding stand a pretty decent shot at seeing potentially significant accumulating snowfall. So Redding is in the valley, although again, Redding is anywhere from about 500 to 1,000 feet in elevation, depending where you are in town. So that part of the far northern Sacramento Valley could definitely see some snowfall from this event. The Bay Area hills and mountains will certainly see snow next week. I think it's a slam dunk up at 2,000 feet, and it could very well happen down to 1,000 feet, which is pretty low. And there are some major roadways in the Bay Area that are at or near 1,000 feet. So there could be some travel disruptions from snow in the Bay Area. But not, again, I don't think it's likely to happen at sea level, but but there could be a lot of white hills around, and some of that snow may be within certainly within easy driving distance, and perhaps even within biking or walking distance of a lot of folks who live closer to sea level. So the potential for novelty snow is very high next week in places where it's unusual, even if it doesn't happen down to sea level, which I don't think it's likely to on any widespread basis. There are a couple of minor exceptions. Along the north coast, there is a chance of sea level flakes, so places like Eureka and Crescent City maybe could even see a snow shower or two all the way down to the beaches. The air mass is a little bit colder up there and it's a little bit easier because essentially the Arctic air hasn't moved over as much ocean by the time it makes it up there. So there is a local possibility for some sea level flakes up along the north coast. The air mass is cold enough that if you get a lot of nighttime clearing, especially in the Central Valley, for example, and an isolated shower moves over in the early morning hours, it is possible that a couple of isolated spots, at sea level and down as far south as the interior of the Bay Area or the Central Valley could see an isolated, sea level snow shower, kind of as I mentioned earlier. So the air mass is not supportive of that happening on any widespread basis, but it's probably a non-zero chance that someone somewhere wakes up to snow at even below 500 feet somewhere. So that is definitely possible. What I do think is going to be more widespread, though, this is the kind of pattern where you get lots of pop-up showers, unstable cumulus clouds that produce lots of small hail and grapple even at the surface at sea level. So even if it's very unlikely that places will see any sort of widespread sea level snowfall, you could still very well see some frozen precipitation at sea level. And this is the kind of thing that often causes traffic accidents along 101 all the way down from the Oregon border into the Bay Area and even sometimes down in Southern California. When these localized but intense showers of small hail, which again can occur when the air temperature is well above freezing at the surface. You just need really cold air aloft, and those hail pellets don't melt by the time they reach the ground. They can accumulate and cause terrible driving conditions on freeways. So that could happen later next week, even in places that have essentially a 0% chance of snow. So again, some sort of frozen precipitation is possible almost anywhere in California next week, but at sea level it would almost certainly be in the form of small hail, maybe some small hail mixed with grapple, which is kind of an interesting precipitation type that is often confused, has sort of a texture kind of like Dippin' Dots, those little ice cream freeze-dried ice cream balls that I still think you can find in vending machines in very random locations. I think it was a bigger thing about 20 years ago. But anyway, the grapple is sort of like a rimed ice crystal. So you can sometimes get snowflakes that start to melt and then get some almost hail-like features as they refreeze. And those can make it to the surface. But the key there is it isn't actually snow, and it can occur when temperatures at the surface are significantly above freezing. So, not to rain on anyone's snow parade, you could still get some frozen stuff at the surface if you're lucky, just about anywhere. It just probably won't be at snow, as in the form of snow, if you're at sea level. But it won't be. You won't have to go too far. I think the most disruptive part of this event is likely to be again in that elevation band from about 1,000 feet, maybe up to 2,000 or 2,500 feet, depending on where you are, that doesn't usually see significant snow and could see, not just a dusting, but actual accumulating snow that sticks to the roads and stuff. Hard to say exactly how much. The models have been waffling around a lot in terms of the total precipitation, but what they are clear on is that will be some precipitation around next week, and snow levels will be very low by California standards, probably down to 1,000 or 1,500 feet and locally lower. So that's sort of what I'm thinking for next week. I'm sure there'll be lots of cool photos. I'm sure somebody will send me an angry message saying, hey, I live at 200 feet and it snowed at my house. I will not be surprised by that on a localized basis. But what I would be very surprised by is if hundreds of people say, hey, it snowed at my house at sea level in San Francisco or Sacramento. I don't think that's likely during this event. Stranger things have happened, I guess, but this just does not appear to me to be like the kind of pattern that would be required to get these to get that kind of effect. Despite what some of the models are depicting, I think there's some reasons to not believe their explicit snow predictions for the lower elevations. And I will note that today, I just looked at the latest model update about 20 minutes before this conversation started. They sort of backed off on that element of it anyway. So the other thing about next week, and it's possible I'll pick up the other half of this office hour then. That's kind of why I did a short one now, so I could do another short one next week potentially. There is some divergence in how much water might fall. Right now, the ensembles are actually suggesting that the overall amount of precipitation in California won't be very impressive. In fact, it might even be less than the average amount still over the next couple of weeks. So the ensembles are suggesting that Northern California might even still see below average precipitation, slightly below average, but nothing too impressive over this period. The individual operational model runs, some of them are really wet. The GFS in particular is extraordinarily wet for portions of the Central Coast, but even that's at odds with its own ensemble, which is much drier for California. So right now, not overly concerned with flood risk or really heavy precipitation risk, especially because temperatures are going to initially be so cold that a lot of this precipitation almost everywhere is going to be falling as snow except right at sea level. So there won't be a lot of immediate runoff. We'll see if there's an evolution towards warmer or wetter systems later on, but right now this looks like this cold pattern will slowly taper off, gradually get less cold with less precipitation, which would probably be the least dramatic outcome. But next week could be pretty dramatic in some spots. Low elevation snow, hail showers down to sea level, some roads through the hills that rarely see snow accumulations could see them, so be prepared for that. And I will add, this is going to add, another robust chunk, at least a foot or so, probably, of snow to the Sierra Nevada. Again, not quite clear how much snow will fall there. 1 to 2 feet is actually not very impressive for the crest of the Sierra, if that's all that they get. If some model outcomes are correct, there could be more than that, which would be a little more disruptive. But right now, I think this is going to be an interesting event. Not so much for the absolute amounts in the high mountains, but more for the fact that there's any at all accumulating down at 1,000 or 1,500 feet in a lot of places. So that'll be what it's interesting for. Let's see. The only other thing I really wanted to cover, and then there's not too many questions today, but if you have any, I can run a little bit past the half an hour. So feel free to add them now, and I'll answer them when I wrap up. Is that there is a really large snowpack in the Sierra, and it's going to grow even a little more over the coming week. It's well ahead of average for the date. It's even ahead of average for the seasonal maximum in a lot of cases. The April 1st canonical maximum. That's good news from a drought perspective and from a high elevation wildfire perspective. So if we're talking about those unusually high elevation fires we've seen in recent years, like above 7,000 feet in the coniferous forests, this is probably going to put a significant damper on those this year. It's much less likely to have a lasting reduction in wildfire activity this season in that middle elevation band between about 4,000 and 7,000 feet, where it will initially, so I think there'll be not much of an early fire season in those elevation bands, but come late summer and fall, once that snow inevitably melts, it'll really just be a question once again of do we see severe heat waves and severe wind events in that window, or any major lightning events, because by that point everything will dry out. And of course, the more moisture there is, the more seasonal growth of brush and grass there is. So at low elevations, wet years are often make for worse fire years, because there's more growth of grass and brush, which then inevitably dries out by late summer, early fall. So a wet and mountain snowy year like this is likely to produce a fire season that is heavily weighted towards the lower elevations. The middle elevations used to have a dampened fire season historically in years as wet as this one, but that is changing in a warming climate where those middle elevations melt out early, where that increasing evaporative demand removes a lot of that excess moisture off the landscape anyway, but you do have a lot of extra growth of the brush and grass in those middle elevations. So I think the clearest effects will be probably more fire activity in grasslands and in brushy regimes and in these transition zones in the woodlands. Probably less fire activity this coming season at the very high elevations in the high mountain forests. In between, it's really going to depend increasingly on how hot and dry and windy it gets towards the end of fire season, so stay tuned for that one. And then a last point about sort of snow in a warming climate. We know that the average snowpack in California and the West is decreasing. It already is in a warming climate. But the interesting thing is the very largest snow years do not appear to be decreasing. So what we're actually losing are all of the ordinary snow years, or the sort of the modest snow years. In those years, the snow really seems to be decreasing quite a lot, but we're still getting these individual huge banner snow years. In fact, in some cases, record-breaking snowfall amounts, even in a period when the average amount of snow in the mountains is decreasing. This may sound weird, but it actually makes a fair bit of sense if you think about it from a thermodynamic perspective. Essentially, you get fewer opportunities for snow and more melting in between snow events because of rising temperatures and increasing evaporative demand. But because a warmer atmosphere has a higher potential to hold water vapor by about 7% per degree centigrade of warming, the very heaviest snow events, if you do have cold enough temperatures, even if it's just marginally cold enough for snow, have the potential to produce more snow than they did in a cooler climate. So there's these competing effects, where the warming temperatures mean that there are fewer opportunities for snow and more melting of snow, but also more opportunities for extreme snowfalls when conditions do align. And that's kind of consistent with what we've seen with like Blue Canyon snow records, for example, or Western Sierra snow records, where when you get high enough in the mountains, you do see that mean decrease in snowpack, but you also see either a non-decrease in the extreme snowfall events or even a slight increase. And there's a little bit of research on this, not a lot, honestly, regarding extreme snowfall events versus mean snowfall events in a warming climate. But there's a lot of reasons to believe that in many places, the extreme snowfall events will, at a minimum, decrease much more slowly than the average snowpack. And in some localized cases, especially in high mountain areas or places that are susceptible to huge bursts of snow in transition seasons, you might even see slightly more extreme snowfall events in a warming climate. Not because the temperatures have gotten colder, but precisely because they have gotten warmer, but you're still on the freezing side of that all-important freezing threshold, 32 degrees, 0 degrees Celsius. So anyway, just some reflection there. Not a whole lot of research on that. If anybody wants to do a study on it, let me know. Not something I'm planning on leading in the near future, but I would be very interested to know the answer formally beyond that sort of pontification and some informal figures that I've seen from other folks over the years. Okay, a few quick questions. A quick question about, with all the snow that's fallen in the Sierra and filled reservoirs, was this going to help with the headwaters of the Colorado and therefore downstream lakes Meade and Powell? Well, obviously the water in the Sierra does not flow into the Colorado, so directly no, but I think your point is that it's also been pretty snowy in, say, Utah and northern Arizona this winter. And so, of course, that does flow into the Colorado Basin, and that is good news. So I do think that probably this year's snowpack in the Southwest averts the worst case short-term outcome. So I don't think we're going to necessarily hit dead pool, as had been a possibility as soon as like this fall, potentially. That's probably less likely after this winter. But that's probably all it buys us, honestly. I don't think it really changes the trajectory. We'd need like year after year after year of conditions like this, plus good monsoons. And last year was a pretty good monsoon, and this is a pretty good snow year, so it is going to buy us something. Perhaps just make this process of figuring out how we're going to allocate Colorado River water moving forward even more drawn out, because the absolute crisis point is pushed ever so slightly further out into the future once again. But we still, this problem is not going away. We need to go back to the 20th century when the climate was cooler and when evaporative demand was a lot less to get back to baseline water levels. And then also we already had an unsustainable level of withdrawals from the Colorado River, even if we had a 20th century climate. So there's this is not just a question of climate change, but climate change has definitely made the problem worse and is going to continue to make it worse on average, even though we will get some better years. And this is, fortunately, this year does look like it's shaping up to be a better year in that regard than some of the recent ones. Is the weakening of the polar vortex, does that have anything to do with anything with the upcoming cold weather forecast? It does look like there was just a sudden stratospheric warming, an SSW event. I don't really have time to go into the details of what that is in this conversation, but suffice it to say that they can affect lower latitude weather conditions, but it takes time. It usually takes at least a couple weeks and sometimes a couple of months for those effects to propagate downward from the stratosphere back into the troposphere. So the events coming up next week are almost certainly unrelated and are evolving independently of that, because that SSW event just occurred yesterday. It's too soon. So could potentially affect spring weather, but it also might not. Each one is different. This is what this is one of the conclusions of research on the sudden stratospheric warmings and the tropospheric polar vortex disruptions, is that they do affect weather in different places, but each one affects the weather essentially in a different place, and not all of them affect the weather at lower levels of the atmosphere at all. And so honestly, it doesn't really help us make a lot of predictions about what might happen in the short term yet. We might get better with using it as a skillful predictor in the future, but right now it's kind of a crapshoot, honestly. Let's see. Quick question about how many feet, I'm assuming, of snow might we see in the Bay Area, places like Grizzly Peak, around Berkeley, which is about 1,700 feet. Well, I definitely don't think we're talking about feet of snow in most places, especially not at 1,700 feet, which is, not among the highest Bay Area peaks. The Bay Area does have, there's Mount Tam in the North Bay, there's Mount Diablo, Mount Hamilton, and then the crest of the Santa Cruz Mountains, all of which are above 2,500 feet elevation. Those are the kinds of places that actually might see, real significant, 6-inch plus snow accumulations, plowable snow. And some folks do live up there, and there are some roadways up there, so that could be interesting. Down at 1,700 feet, it's likely more to be a novelty, a dusting, maybe an inch or two, but it could happen down at 1,700 feet for sure. And, if you are under a localized heavy shower, maybe a bit more than that, even down to 1,700 feet. So the possibility of the peaks, in the East Bay Hills seeing a dusting or more is actually pretty high next week. Santa Cruz Mountains, very good shot. Mount Tam, Mount Hamilton, Mount Diablo, almost a sure thing. The real question is what happens down at around 1,000, 1,500 feet, and do we get snow down to there? And if we do, is it, do we get significant accumulations? It may be cold enough that could happen, and so that's I think on the localized spots down at 1,000 or 1,500 feet that see significant accumulations. That's where a lot of the travel challenges and disruptions are going to arise because the infrastructure is not really designed for that at that elevation. Let's see. Was the 1970 snow event associated with an unmodified Arctic air mass? Essentially, yes. As far as I can recall from the charts, that's more or less what happened. And there have been some. The early 90s wasn't really much of a snow event since it was just too dry, but it was a major and damaging freeze event. And there were some snow flurries down to sea level, even in San Francisco and places like that. And I forget which year it was in the early 90s. Also, there was one in the late 80s similar. So they weren't really widespread snow events, but they were widespread deep freeze events that resulted in snow flurries all the way down to sea level, just because the air mass was so cold, but there was so little moisture, which is, of course, the challenge. It's really a trade-off. Air masses that are cold enough for widespread snow usually don't have enough moisture or upward motion in the atmosphere to produce the snow. Air masses that have the moisture and the upward motion usually aren't cold enough to produce the snow. So that's sort of the tension there. I see somebody asked about the sudden cooling of the Pacific Ocean surface by 5 degrees Fahrenheit. Honestly, I have no idea what that's about, but it certainly hasn't happened. It's possible somebody's talking about a very localized temporary cooling of the nearshore waters, which can happen essentially as offshore winds either induce upwelling of cold water from beneath versus not. That's pretty much the only way to get a sudden change, unless you've had a massive hurricane somewhere, to get a sudden change in the ocean temperature. So it's very likely localized, temporary, and not especially consequential. This is not something that's happening over a broad area. And it does happen occasionally when we shift from sort of strong onshore winds to more northwesterly winds down the coast. I think the last question I'll answer before signing off today is it too early to talk about spring snowmelt leading to potential flooding in the Central Valley? I don't think it's too early. I mean, it's too early to be specific about it because we don't know the sequence of events. I do know that there is an elevated level of concern this year. I've spoken with folks at the Department of Water Resources. They're keeping an eye on it. So any year where there's a very large snowpack that's likely to persist through March, which I think is the case this year, or it may even grow further through March, there's some level of concern, particularly because a lot of that snowpack is in the southern half of the Sierra Nevada, which drains to, on the western slope at least, to the San Joaquin watershed. And the San Joaquin watershed has honestly a lesser degree of flood protection than the Sacramento watershed to the north. So that's always, something that's on the minds of flood managers and water managers. What we'll really be looking out for, I mean, you could see, at a reasonable amount of snowmelt where the worst thing you get is, rivers at bank full or minor flooding. That would not be a big problem if it's gradual. But there's really two things to be looking for. One is a late season warm storm. So one of the things that would be a big problem is to get a a warm atmospheric river in March or April. That would be where it rains a lot and where the ambient temperatures are just well above freezing, where there's a big snowpack. That would result in a big snowmelt pulse. And the other thing is, even absent a storm, if there's just a big early season heat wave in March, April, or even May, potentially early May at least, that could also result in a big pulse of snowmelt. So those are the two kinds of weather events I think we'd be keeping an eye out for in terms of snowmelt flood risk this spring. It's too early to know specifically to what extent either of those things might happen. So the potential is there just because there is a large snowpack, but there does not mean that potential will necessarily be realized, depending on the sequence of weather events that actually unfold. All right, with that, I think I'm going to wrap it up. I may do another short office hour next week for the events that are unfolding. I'll probably try and have a blog post early next week as well, since there will be some quite low snowfall, and it could affect some cities that rarely see it. Reading, the North Coast could see some flurries, and then a lot of folks living in the lower foothills or even the higher hills around the Bay Area could see some real snow. So stay tuned for that. But in the meantime, this weekend looks actually pretty mild, so you can get out there and enjoy the weather before it gets much colder next week.